This is chapter 7. From the last video, we talked about reflection. Now we talk about refraction with R over here. Before we talk about refraction, let's say we have a car that with two wheels, or let's say we have two wheels connected. So when this one is going from, let's say from sand surface to this surface is concrete surface, okay? So those two wheels are coming down. What will happen when they hit? So this one is sand. This one is concrete, okay? So usually the wheels runs slower in sand and runs faster in concrete, okay? So if it goes straight like this, nothing will happen, okay? After they hit the concrete, they continue going through the concrete. So what happened if I switch the order? See what happened, okay? So now let's say from concrete to sand, okay? So after we switch it, when it go down here, it will continue going down. What happened if I turn this one a little bit? If I put the wheel go like this is top wheel. If you have two wheels connected together, coming from concrete, that means higher speed, to the sand, that is lower speed, what will happen? So this wheel is going to hit the sand first. When it hit the sand, let's say the next step is going to be like this, while the other one has not hit the sand yet. So this wheel is still on the concrete, this one hit the sand. So the one that is hitting the sand is going to run slower, where the other one still in touch with the concrete is going to run faster. So when that happens, it's going to change the angle. Okay, so this one is going to change the angle because you're going like this. The first wheel hit the sand, it's going to slow while the other one's still fast. That's why it changed the angle. So that is physically for the wheels. What happened for the light is the same thing. When light can go from a very high speed medium and then reach a lower speed, lower velocity medium, it's going to bend. Okay, so I'm going to put the optical axis or the normal. So this is a normal. Okay, if we have a reflected beam, remember this one, this angle, theta, is called incidence angle. Okay, this, I'm going to call this angle phi. So what happened is when this beam get in from air, like higher velocity, into somewhere like water, lower velocity, the angle is going to bend. If this part, if the medium below here has a higher density or with a smaller velocity of light, then it's going to bend toward the normal. In this case, if it's coming from air to water, theta, the angle theta, will be greater than the angle of phi. Okay, so from high velocity to low velocity, we are going to see the change in the refracted angle. Okay, same process can be reversed. That means if I have a light beam coming from here, from water, and let it get out, the angle will bend. Okay, still phi will be less than theta because the light will have different velocity in these two media. What is important about this one? Okay, there are a few things. The first thing is people actually can make a magnifying glass out of it, or the lens. Okay, so how does that work? Okay, so what happens is if you have a lens, for example, like this, and when the light coming in here in this way, if you try to draw the surface, draw the normal, you see that it will bend in this way. Okay, and then it will bend again. So that means it can focus the light to a spot. Okay, when you were a little kid, maybe you have played with this, the magnifying lens. That means we can gather all the light to focus on one point. Sometimes we can light up a match. Okay, there's another important application. For example, if you have a media like this, so this media, the light has a very low velocity. Here's the air. So what happens is if you have light, let's say coming like this angle, and it would come out with a bigger angle. So I'm going to draw a normal here. So it come in with this angle, okay? And it's going to go out in a bigger angle. Remember, the angle is between the beam and the normal, not this angle. It's this one. Okay, so the question is, if you increase this angle, what happened? When you change the angle to, let's say you increase this angle, you also increase the other angle until a point that when you try to get it over here, it cannot be increased anymore because it goes horizontal, okay? And this is called totally internal reflection. That means from a media that has a very low velocity for light, when it come out to air or to something that with high velocity of light, it's going to bend and reach a critical angle. That critical angle, that is, it cannot be bigger anymore because if it get bigger, it get back into the medium. Okay, so this is called a critical angle. So what is the use of critical angle? With that critical angle, that means for the beam, I'm going to draw it again. So this is a media. And if the beam go in this angle, it can never go out anymore. You can always have totally internal reflection. And this is exactly how the optical fiber work. The light inside or the optic beam inside cannot go out of the media because it already extended the critical angle. So it can only reflect it. So this part, it can be flexible. You can bend it, you can turn it, make sure that everything is still create a condition of the angle that is greater than the critical angle, so the beam can never go out, okay? So for files or for any optical cable, they use this principle to make things work.